Hello everyone. In this video, we're going to go over question number 5 in section 10-1, which is referenced with 10.1.10 in the textbook. The main goal here is to figure out how to use the tools built into MyLab to help us figure out the scatter plot, the linear correlation coefficient R, as well as the results of the hypothesis test to determine if there is a linear correlation or not. So here we're using the given data set that completes parts A through C, and we're given a significance level of 0.05. We can see that this is bivariate data, so this is the first data point, the second data point, and we could really put all of these on, just do this by hand, but it's kind of tedious because they're not ordered. So what we could go ahead and do then is load this in StatCrunch and have that tool help us out. So open in StatCrunch. And you can see here, unlike before, we have two columns of data and we're not given a summary. So we're going to have to keep in mind that we'll actually have to select the appropriate columns. So to get the scatter plot first, let's go to the graph and you'll see a scatter plot option. Clicking on that, we can select X as the X variable and Y as the Y variable, since we're just using general data. And really, for the rest of this, we won't need it. It will just help us add additional information, such as labels, if we were using this to create a presentation or something of the like. So if we click compute, we can see this right here is our scatter plot. We have this one outlier up here, but overall is pretty much linear. So that is another feature, or here's another feature you can do. You can highlight certain parts of it and it'll then show you that in the data set. So looking at our options, we see D is the one that looks most similar to it, just scale is a little bit different. But remember that the scale does not affect the linear correlation coefficient. So checking the answer, nice work. Part B. Here we're asked to find the linear correlation coefficient and determine whether there is sufficient evidence to support the claim of linear correlation between the two variables, round with 3 decimal places as needed. There are 11 data points. You could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And just to maybe call it out in the view an example, you could compute this by hand. Let's find where it is. I'll show you essentially how to do it by hand. It would be a couple tables right here to do it. So you would have to count, you would see each individual X value, you would, each individual Y value, you'd have to square each one, you'd have to then multiply each pair, and then you would calculate the sums to get the appropriate computations. And then when all is said and done, you would plug it into this formula and you would be able to work through that to get the linear correlation coefficient. So to get that using StatCrunch, let me show you how to do that instead. So let's exit the view and example since the numbers are different. So we can't get it from the scatter plot. What we do need to do, it is the linear correlation coefficient R is a type of statistic. So we do need to go to the stats menu, and correlation will help us, will give us the information we need for regression. This is a simple linear regression, and it brings up a series of prompts we need to fill out. So we're going to select X as the X variable and Y as the Y variable. We don't need to do any sort of extra grouping. And this will make more sense once we have regression, but the correlation is helping us determine the slope of the line. So whether it's increasing, so it's a positive slope, or decreasing, so it's a negative slope. So I'll say a few words about this, but we don't need to edit anything else here. If we hit compute, it gives us a ton of information. Let's take a look at what we need. Well, right up here at the top is the correlation coefficient, which is 0.8163. We don't need the 3. We don't need to round. So this is that. So I'm going to copy that, go back to our problem, paste that in, check answer. Fantastic. Now the last thing, well, this is not the last thing, this is still part B. We are asked to use the linear correlation coefficient found in the previous step to determine whether there is sufficient evidence to support the claim of linear correlation between the two variables. So let's remember our steps. If we were to consider the null hypothesis for the testing linear correlation, we would say that rho is equal to 0. The alternative hypothesis, H1 or HA in terms of StatCrunch, is that rho is not equal to 0. So in the case of the null hypothesis, we're saying there is no linear correlation. And sorry, that faded. That's just how the tool works. But in the alternative, where rho is not equal to 0, that means there is some sort of linear correlation. So we'll need to consider the rejection region. So if I click to view the table of critical values, n is equal to 11.0, I believe it was 0.05. Yeah, 0.05. We will see the critical values are 0.602. So less 0.602. So we have this as our linear correlation coefficient. So if we have those two values on the side, zeros in the middle, so this is the negative 0.602 and this is the positive 0.602. The R is actually over here. And then remember, this right here is part of the rejection. Sorry about the bad writing. That's part of the rejection region. Bad writing, I'm writing with a mouse, so not my best work. But since we're in the rejection region, we reject the null, and then we end up at the alternative, which says that rho is non-zero. So there is sufficient evidence to support the claim of linear regression between the two variables. Let's go ahead and check that. Well done. Another thing that I'll go ahead and mention is if you looked at this right here, you can see that the p-value for the slope, which again, we'll talk more about this in section 10-2, this is lower than the significance level. So the p is low, the null must go. We reject the null, same conclusion as using the critical region method. All right, then the last thing that it wants us just to put these ideas together. So remember that regardless of the scatter plot, you can always compute the linear correlation coefficient. So to talk about linear correlation, you still need the scatter plot to make sure that you're dealing with something that's linear. So like if your data was B, you might still say the hypothesis test might still say there's a linear correlation, but you have to actually discard all of that idea because you don't have a data set. And linear would basically fall off. We'll talk more about that in 10-2. But in part D, the scatter plot allows us to see this single outlier. And remember, technically the linear correlation here without that outlier is 1. It is perfectly straight data. So this one outlier changed the linear correlation by almost 20% or 0.2. So that is something that the scatter plot allowed us to see. So the scatter plot reveals a perfectly straight line except for the presence of one outlier. Checking the answer, and then we are done with this question. So take your time going through the homework, use the tools to help you improve and increase your understanding, and I'll see you in class.